Hello, in this video I am telling you galvanometer as a voltmeter. So you can see this figure that galvanometer is used in parallel with the resistance. Okay, so it is an internal resistance, it is a volt. So resistance in voltmeter is greater than that of galvanometer. Okay, so ideally R is infinity. So but internal resistance is 0. Okay, when galvanometer uses voltmeter. So we are studying voltmeter is connected in parallel with the measuring circuit. A high resistance is connected in series with galvanometer to convert it voltmeter. So V is equals to Ig, capital G plus capital R. V is range of voltmeter, Ig is full reflection current, and R is high resistance. Okay, now we are discussing potentiometer. So you can see that this is a battery and this is a galvanometer. So here it is very sensitive and accurate device, exact potential device. Cell it is a EMF, cell is EMF compare, and cell is internal resistance. So when E1 is greater than E2, then I is equals to E1 minus E2 upon R. It is anti-clockwise. When E2 is greater than E1, then I is equals to E2 minus E1 upon R. It is a clockwise. When E1 is equals to E2, I is equals to 0, then no current to pass. Okay, so you can see this is a potentiometer. So this is a primary circuit and this is a rheostat. Then this is a secondary circuit. Then this is a galvanometer. So V is equals to IR. If at point P there is a no deflection in galvanometer, then E is equals to BP is equals to KL, and where K is potential drop per unit length. So E is equals to KL, E1 is equals to KL1, E2 is equal to KL2. So E1 upon E2 is equals to L1 by L2. Now internal resistance of a cell E is equals to KL1 without resistance, and V is equals to KL2 without RV. So it is become E upon V is equals to L1 upon L2. V is equals to IR is equals to I capital R plus small r. So after calculating, you will find out the small r is equals to capital R. E upon V minus 1. Small r is equals to capital R. L1 minus L2 minus 1. Now we will study superiority of potentiometer over voltmeter. So you can see this figure. This is a very magnetic field and so NIAV is equals NIAV sin theta is equal to C phi. Here theta is 90. So potentiometer show diffraction, but in voltmeter show diffraction, but potentiometer null diffraction. In voltmeter current drop, V drop, that is not accurate. But potentiometer I is equals to 0. That is ideal voltmeter, that is R over infinity, R over internal resistance. Bar magnet, here M is equals to NIA, ammeter meter square. This is the NS plus M minus N. So M capital M is equal to M plus 12. It is a pole strength. Small m is equal to capital M plus 12. That is ammeter meter. Plus Q minus Q 12. P is equals to Q2L. So it is a plus M minus M. When we convert it to two part, pole strength is directly proportional to L and pole strength is directly proportional to area. Magnetic field line. So isolated pole does not exist. M NS plus M minus N NS. So here you can watch. Magnetic field lines make closed curve unlike electric field line. Okay. Sorry. So no two magnetic field line can intersect each other, so it is not a possible. So then it is plus Q minus Q. Toward distance it is a P is equals to Q dot 2L. So 2L is equals to 0.84. So magnetic dipole moment is capital M is equals to M cross 2L. where m is pole strength. L is equals to pi r, 2l is equals to 2r. So capital M is equal to m cross 2l, capital M equal to m cross 2l, capital M equals to m cross 2l upon pi. So you can show this when there are two, m is equals to m l by 2, m dash is equals to m1 square m2 square. Then after calculating you will find out m root 2. Okay, so magnetic dipole, it is a ns, so capital M equal to m into 2l, s to n, m is equals to nia. This is a magnetic dipole. So this is a ellipse, t is equals to 2 pi upon capital T is equals to 2 pi r upon b. So magnetic dipole moment of revolving electron. So after calculating you will find out magnetic dipole moment due to orbital motion. M is equals to EBR by 2. So in electrical circuit EELBML, angular momentum is momentum of linear momentum L is equals to R cross P. So after calculating orbital angular momentum is equals to L cross is equals to MBR. M bar is equals to ML plus MS. Okay, so ML upon L is equals to E upon 2ME. Okay, so this is a gyromagnetic ratio of orbital motion, and spin motion ms upon s is equal to E upon me. It is a gyromagnetic ratio of spin motion, and according to Bohr theory, so after calculating you will find out L is equal to m is equal to nh upon 2 pi, ml is equal to n eh cross upon 2me, n eh upon 4 pi me. So ml directly proportional to n, it is important. So after calculating mb is equal to eh upon 4 pi me, that is 9.27 to 10 to the power minus 24 meter square. This is a mu Bohr magneton. Okay, Gauss law of magnetization. So magnetic flux passing through a closed Gaussian surface is always 0. So phi is equals to v dot dA. So del dot v is equals to 0, divergence v is equals to 0. And this, that is magnetic monopole does not exist. So curl A del cross A is equals to 0. That is a conservative and irrotational vector. So divergence A and divergence is equal to solenoidal vector. Okay, so now this is a P plus Q minus Q. Dipole moment is P is equal to Q to L. Torque is tau is equal to P cross E. Axial डायरेक्शन में E is equal to 1/4 pi epsilon 2 P upon R cube, और इक्वेटोरियल में E is equal to 1/4 pi epsilon P upon R cube. Work done is W is equal to PE cos theta 2 cos theta 1 minus cos theta 2. Potential is minus P dot E, and M is equal to M2L. Tau is equal to M cross B. It is a long solenoid equivalent to bar magnet. So you can see this in magnetic field B is mu naught upon 4 pi 2m upon r cube, and equatorial it is mu naught upon 4 pi m upon r cube. Work done is W is equals to mb cos theta 1 minus cos theta 2, or potential energy is U minus mb. So this is for this class. Thank you.